A confirmation regarding the audio, please, guys. If you're able to hear me out perfectly well, kindly confirm the same. Thank you. So, hello, a very warm good evening to all of you, and welcome to Byju's Exam Prep IAS. Welcome to another session of climatology, where we shall be further proceeding from the areas that we completed till yesterday. So, we were looking at the portion of humidity and precipitation. So, we familiarized ourselves with the aspect of humidity. How is it that humidity gets influenced by the conditions of temperature? How temperature ends up increasing as well as decreasing the water carrying capacity that any air parcel can exhibit. Then we looked at the factor that when is it that we experience saturation of air? What is it that we refer to as the air being saturated? When is it that we experience condensation to happen? Where we saw that an air parcel, when it is cooled beyond the point of saturation, that is when we experience condensation. Now, if that temperature at which the saturation is reached, if that temperature is above the freezing point, you'll find liquid droplets of water as condensates. In cases where you have the saturation temperature to lie below freezing point, in that case, the condensates consist of ice particles or solid ice. And accordingly, we looked at the formation of dew, what is dew point temperature. We looked at the cloud formation, why is it that we experience thunder and lightning, and also different types of clouds which are in existence. Now, today we are going to initiate the discussion from certain disasters that you will read in disaster management as well. And then after that, that is cloudbursts, hailstorms, etc. And then after that, we shall be proceeding into the types of rainfall, types of fog, and then into the portion of cyclones, air masses and cyclones. Now here, in all these portions that we are going to study, that is cloudburst, hailstorms, types of rain, types of fog, in all these, the same basic principle is followed. The same basic principles are observed, right? The better you are able to relate to those basic principles, the better the understanding will be. And what is that basic principle? It is very simple, that an air naturally will consist of water vapor. Now, if you start cooling down the air, or if the air experiences a rate of cooling, eventually the carrying capacity of the air will reduce to such an extent that whatever water vapor it has been carrying, that in itself is enough to make the air saturated. And if there is cooling beyond that, there will be condensation. So, if you remember the basic fact, or if you are able to relate to the basic fact that sudden cooling of air or cooling of air beyond a certain temperature will lead to condensation, that will help you understand that where that condensation is happening and what are the characteristics or features of the condensation which ensues thereafter. Okay. Now, we'll proceed with the portion of cloudburst. Before that, a quick question I will address. Yaram Seti, you had a question. Sometimes in other countries without clouds and on under normal conditions, thunder strikes. Due to what is the reason? So, what do you mean by normal conditions here? Do you mean clear skies? So, even in clear skies, there can be a thunderstorm or there can be a lightning only in cases when there are a lot of dust particles in the air, and those dust particles, they are in a consistent state of motion and then they have suddenly become stable. So as a result of that, these dust particles, they also end up gaining some charge. But nonetheless, that is a very rare phenomena, 1 in a million of such instances. Okay, so this only happens when there is a lot of turbulence in air and you have the dust particles which end up gaining that charge. Okay, right. How do rain and snow fall together? First of all, when you observe snowfall, we observe snowfall only in restricted parts of the country. That is in the region of Jammu Kashmir, Ladakh, Himachal, Uttarakhand, Sikkim, and Arunachal Pradesh. Rest of the areas, if you are saying there is snowfall, it is not snowfall, it is hailstorm. That is where you find ice particles and raindrops falling together. Otherwise, in certain cases, even if there is some raindrops along with the snowflakes, that is where those raindrops might not have refrozen while they are coming closer to the ground, whereas the snow particles, they would have. Okay? Turbulence refers to disturbance. Yes, Pranay, we can say that. Right? So now we start with the portion of cloudburst. What is a cloudburst? So the figure in itself is very self-explanatory, where the cloud is unable to hold its content together anymore. And whatever is present in the cloud, it starts coming down all at once. So in the area which experiences the cloudburst, there will be sudden onset of rainfall and huge quantity of rainfall which will be received. So in general, a cloudburst is a localized but an intense rainfall activity. Very intense amount of rainfall, very heavy amount of rainfall in a very short duration. Rainfall of 10 centimeter or more in an hour over a roughly 10 by 10 kilometer square area, that is classified as a cloudburst event. Now, why is it that such cloudburst will occur? What events are there which will lead to the eruption or occurrence of these cloudbursts? So first of all, you have to understand that majorly and in most of the cases, cloudbursts occur across hilly areas, majorly. So in majority of the cases, they occur in hilly areas. Sachin, the question that you have asked is other way around. The question that you have asked is why in places like deserts we see minimal rainfall. It is the other way around. That wherever we see very minimal rainfall, those areas turn out to be desert areas. Why some areas receive more or less rainfall, that is dependent on factors of physiography, that is dependent on factors of cloud formation, that is dependent on the availability of moisture in the winds which are coming in, which are brought about. That is where. Okay, right. Now, here, when we talk about the cloudburst, in majority of the cases, they occur in hilly areas. However, in rare occasions, they do occur over plain areas. Now, what is this phenomena? So this happens when the cloud becomes unsustainably large and is unable to hold the contents within itself. So suddenly all the contents give way. Imagine that you have a plastic bag. In your childhood days, you all would have done this, that while you are playing, maybe you don't have enough water in between. So you would carry water in plastic bags to the field to pour it on the ground, or maybe even use it for drinking purposes. Many of you would have done that. So while filling water in the plastic, you would have observed that in the initial stages, the plastic is able to hold water, lot of water. But a stage comes when the plastic consistently you are filling it up with water, right? But a stage comes where finally even 1 millimeter of water that you will add in that plastic, the entire plastic bag will give way and all that water will immediately be drained, isn't it? All of us would have come across that scenario where the plastic suddenly bursts out and all that water significantly drains out. Something similar happens in the case of cloudburst event as well. The cloud keeps on growing, growing, and suddenly it becomes so unsustainable that everything gives way. So why does it happen is here, if you observe, let's suppose a hilly area. Now hilly area here will have the winds, moisture carrying winds or moist winds. Moist winds. Now this side of the mountain is referred to as the windward side. Windward side. Now here, the winds which are laden with moisture, they are in a way forced to rise up. They don't have an alternative that I don't like this hill, so I will not climb this hill. I'm too tired, so I will not climb this hill. No, they are forced because after them, there are more winds which are en route. So they will be pushing these winds uphill. As these winds are pushed uphill, what will happen to the temperature of the air? The temperature, will it increase or will it reduce as it climbs up the hill? What do you think? It will reduce significantly. The temperature will reduce, it will start cooling. Now, as the temperature starts reducing and it starts cooling, there will be condensation. First, the air will reach saturation, but because it is laden with moisture, it will be saturated fairly easily, and there will be condensation which shall happen. It will lead to formation of a cumulus cloud in the initial stages. Then more winds push in, more winds rise up, more winds they undergo condensation. And as more winds undergo this process, this cumulus cloud very quickly gets converted into a cumulonimbus. Very quickly, it gets converted into a cumulonimbus. And when we say a cloud gets converted into cumulonimbus, it gains a vertical profile. The cloud starts expanding vertically. And that is when it will become significantly thick, maybe kilometers thick. That is when the clouds start appearing darker and blacker in appearance. Now, more winds are coming in. So when more winds are coming in, what will happen? The clouds will enlarge. The clouds will be further enlarged. Isn't it? The clouds will be further enlarged. And it is the movement of the winds in a way which are going to keep the clouds afloat. Because imagine there is that kind of a plastic balloon of sorts, if you can provide an analogy to the clouds, how they behave, to a kind of a plastic balloon. The clouds also are able to float freely. Similar is the case with the plastic balloon. Now, the only thing keeping the plastic balloon higher up is the movement of the winds. The movement of the winds, as long as they support it, the clouds will remain in place. Now, with this activity, as more and more condensation happens, the cloud grows unsustainably large. Cloud becomes unsustainably large. Unsustainably large means it is unable to hold its weight together. So why is it still not causing rainfall? Some amount of raindrops here or there will occur, but the consistent movement of the winds, that will consistently be pushing up the materials upwards. They will be keeping the materials afloat. Now imagine a situation where suddenly this has been happening. Let's say it started on Monday. This has been happening throughout Monday. This has been happening through Tuesday, Wednesday, Thursday. The cloud has become very, very large now. Let's say by Thursday evening, suddenly, for even if for 2 to 3 hours, this wind movement that weakens or that stops, what will happen? If the wind movement suddenly stops, even for 2 to 3 hours, all that cloud which was built up, now there is no force keeping that cloud afloat. So what will happen? It will suddenly give way. As soon as the winds stop moving, suddenly there is no support available to hold the weight of the cloud. It will suddenly give way, and the entire material which is present, it will start gushing down in force. And that is where, in the small area, it is concentrated in a small area. You will never come across a situation where there has been a cloudburst over India. No, it is you. Whenever you read the news story, what do you read? That cloudburst has occurred in Kerala, cloudburst has occurred in the Western Ghats, cloudburst has occurred in Himalayas. Mostly, you will hear about this during the rainy season, particularly during the month of June and July in the region of Uttarakhand and Himachal Pradesh. Chamoli, Pithoragarh, Tiri Garhwal, these are the areas which are Uttarkashi. They are frequented by cloudbursts almost every year. Even the very major Kedarnath disaster which happened in 2013, that Kedarnath disaster was nothing but a cloudburst which happened in that region. Now, what that brings about is intense amount of rainfall in a concentrated area. Very intense amount of rainfall in a very concentrated area, small area. Now, when in that small area you receive such excessive amount of rainfall, what will be the resultant out of it? That area, within a short duration, the rivers will start flooding, the region will get flooded, right? And here, observe 10 centimeter or more in an hour. So, many areas in Rajasthan, they receive around 25 to 30 centimeter of rainfall throughout the year. Imagine 10 centimeter of rainfall in an hour. Imagine how high amount of rainfall that is. Average rainfall that India receives throughout the year is roughly in the range of 130 to 140 centimeter. That is throughout the year on an average. So here you are receiving 10 centimeter in 1 hour. So that is where immense amount of waterlogging will happen, and that will induce a sudden flood like situation. And that flood which is induced, that sudden onset of flood which is induced, that is what we refer to as flash floods. So cloudbursts will always lead to generation of another disaster, that is flash floods. Now, because in the hilly areas, there is that sudden cooling of air which is provided because of the orographic uplift of the air. That is why mostly you experience this in the hilly areas or the hilly regions. Otherwise, in the plain areas, it is a very rare occurrence. One out of every 1,000 events of cloudburst you can observe in the plain areas. But there also, in the plain areas, wherever you observe that, whenever you observe that, the reasoning is the same. And the reasoning is that due to intense heating creates a low pressure, a localized low pressure, due to which the winds rise up. And there is continued convection as the clouds become larger and bigger in size. They keep on growing bigger and bigger and larger. That is when the clouds, they start growing. And when suddenly the wind disappears, all of that will, in a way, result in very heavy rainfall that we refer to as cloudburst. So this is why cloudburst keeps on happening, or cloudburst is observed. Okay. What is centimeter of rainfall? How many of us have no clue how rainfall is measured? Shivam, how can wind provide vertical support? Wind moves horizontally, but as it is climbing up, in this case also here observe, it is a vertical movement of the wind. Here also there is a vertical movement of the wind. That is why. So, okay, fair enough. Rainfall is measured, the amount of rainfall received in an area is measured by a device which is referred to as a rain gauge. A rain gauge. What is a rain gauge is actually a device like a beaker. And in that beaker, you have it is not that big a beaker, in fact. It is narrower. And in that container, you have a funnel on top, and that funnel is put on the beaker. Now, this beaker has got readings, markings in centimeter and millimeter. So, whenever you have occurrence of rainfall, all that rainwater accumulates and builds up. Based on this reading, we get an idea about how much rainfall has occurred in a place. Yes, Pratyaksh, that is true. I had shown you this, but still, nonetheless. So that is how rainfall is measured. This is referred to as rain gauge. That is how here you have millimeter, centimeter. So whenever you come across the readings that this much centimeter of rainfall has been received, that is how it is measured. Why if the funnel is put on top is so that there is no wastage of water, no splash out of water that should not adulterate the readings, so that all the water which is present in that region, it accumulates in the beaker. That is why a funnel is installed on top. That is what is a rain gauge. So what is a cloudburst? An event of intense rainfall activity where you have more than 10 centimeter of rainfall received in 1 hour. Why that happens? When the cloud becomes unsustainably large and is unable to hold itself, it simply gives way, bringing all the materials downwards. Why is it that the cloud becomes unsustainably large? Because of the fact that you have a continued convection which is happening. Generally, the orographic uplift which is provided by the hills and the mountains, they keep on building this cloud significantly. And eventually, even if the wind disappears for a brief moment of time, the entire cloud gives way and everything drops down. That is what we have as a cloud burst. Dinesh, yes, you can do it at home. I don't know what is the trend now. At least in my school days, I remember this was a project given to us. I think it was in class 6 standard, where all of us had to make a rudimentary rain gauge. So I don't think that that is a trend present anymore. Otherwise, we won't have the question. Okay. So that is orographic uplift, Arindam, is basically the uplift provided by the mountain, that is, or a hill. That is what is orographic uplift. Okay. That is cloudburst. Now we come to another event which we experience across the country, which many of us across the country, we refer to it as snowfall. You will find, especially if you guys, I'm sure many of you would be on social media, so you would find that frequent discussion which happens that today Noida received or Delhi received snowfall, today Hyderabad received snowfall. It is not snowfall, it is hailstorm. So what is a hailstorm? Hailstorm is basically that kind of a weather activity where you have large chunks of ice which fall down on the ground surface along with thunder, lightning, and a kind of a stormy conditions which prevail. Whenever and wherever you would have observed this event, most of you would have observed this. Generally, you would have made an observation that this happens during the summer months or during hotter periods of the year, and you have a stormy condition with very heavy wind movement which is observed. There you have large chunks of ice pieces which fall on the ground along with raindrops, and these large chunks, they are destructive in nature. They can break the glass windows, they can break the windshields, and in certain cases, they can even cause death to individuals by directly falling on the heads. So that is hailstorm. Now, why is it that hailstorm occurs? Hailstorm basically occurs due to intense convection. Yes, recently you had this hailstorm in Telangana, many portions of Telangana, and from today onwards, there are few areas in the country which are expected to receive hailstorms. So, from today for the next 2 to 3 days, you can expect or experience hailstorms in certain particular parts of the country. So, why this hailstorm occurs? So, in order to understand that, why this hailstorm occurs, we have to take a look into the necessary conditions which are required to be fulfilled for this hailstorm to occur. What are those necessary conditions? So, for this hailstorm to occur, you need two conditions to be fulfilled. Conditions required. Only in these cases will a hailstorm occur. Otherwise, there will be heavy rainfall, no hailstorm as a resultant. So, what are the conditions which are required? There are two. First is presence of cumulonimbus clouds. Presence of cumulonimbus clouds. This is very important. The other kind of cloud activities or the other kinds of clouds, they cannot support or they cannot lead to the formation of a hailstorm. We'll take a look at why. Then the second is presence of a very intense low pressure region. Okay, presence of a very strong intense low pressure region. Now, wherever you have a very strong intense low pressure region, in those areas, you will experience something. You will basically experience that the winds are attracted to that low pressure, and then on that low pressure, they will start rising up because of heating, etc. They will start rising up. So, intense low pressure region, they are able to generate very strong vertical movement of air. So here, what happens, let us understand. So basically, here, let's consider the ground surface. Let's consider an area, a small area, has received intense heating. Intense heating. And that intense heating will lead to intense or a very strong low pressure. Very strong low pressure. Now, wherever you have low pressure on the ground, it will start attracting winds from all the regions, nearby winds. Now, here you also need a pre-existence of a cumulonimbus cloud type. So here you need the pre-existence of a thick cumulonimbus cloud. Let's suppose. Now, in this cumulonimbus cloud, you will have water droplets, ice particles, all of them will be present there. So let's suppose an ice particle which is present here, it becomes heavy and it starts falling downwards. In the meanwhile, due to intense low pressure present here, the winds start to rise up. The winds actually they come here. When they come over that warmer area, they also get heated up and they start rising up. Now, these are strong winds. These are going to be very strong winds. Right? So, very strong winds. Now, here, now is where the process of formation of hailstorm that is initiated. Now, let's assume this ice particle, one ice particle we'll talk about. This ice particle, very easily, it becomes heavier and heavier. It starts dropping down. As it starts dropping down, because it is very thick, the cumulonimbus clouds are very thick, right? We have seen yesterday what these cumulonimbus clouds are, how they are developed, we have looked at it. So these ice particles, as they start moving down the clouds, they will start accumulating the nearby water as well. Why? Because think about this ice particle. This ice particle, regardless of how small they are, and listen to this carefully, regardless of however small this ice particle is, let's assume it is very small, 2 millimeter square or something like that. But the surface will be very cold. Surface will be significantly colder. So if it moves from an area where there are liquid droplets around, those liquid droplets, after coming in contact with that cold surface, they will also start to freeze. So the ice particle grows bigger. Now still the surface is very cold. As it comes and interacts with other liquid droplets, they will also start freezing. Slowly and steadily, it starts providing a larger surface area for the liquid droplets present in the cloud to accumulate around it and to get frozen. So here, when this starts dropping, slowly it gains size, it becomes larger, and as it is about to drop from the cloud, there it encounters this heavy and strong wind. Very heavy and very strong wind. So as a result of that strong wind, what happens is that this ice particle that is pushed up, that is thrown upwards due to the strong wind. So here, due to very strong winds, it gets thrown upwards. This ice particle will be thrown upwards. Now this ice particle, let me represent it with different color, which is now being thrown upwards. This ice particle will cover a journey, a forceful journey where it is forced through the thick cloud layers. As it is being forced through the thick cloud layer, again the same process will happen, where the ice particle will provide that surface and all the liquid droplets or semi-molten ice particle, they will start condensing around. So this ice particle grows larger in size. It reaches somewhere here. It realizes that it has become too heavy, so it starts dropping down. As it drops down, it further accumulates the materials around it and it becomes larger and larger. Eventually, again as it is about to leave the cloud, it experiences that strong vertical updraft of wind. Again, when there is that strong vertical updraft, again this is thrown up. This process is repeated for 3 to 4 times. And when this process gets repeated, eventually this ice particle further goes up, becomes heavier and larger in size. Eventually, it will become so large that the gravitational pull will be the more dominant factor. So when it becomes so very large, that is when it starts to drop and drop with a force. While again coming down, it will accumulate the materials and the condensates around it. But by now, it has become very large. So now, even the vertical movement of the winds, they are not enough to stop it because it has become so large. And that is when these simply drop out. Now, when they drop out, they experience warmer temperature because the temperature on the ground is higher than what you experience in the cloud. So some of the outer portions, they start to melt, so their size reduces slightly, but nonetheless they are still large enough to fall on the ground surface as solids. So that is when they fall on the ground surface as solid ice particles, and we refer to them as hailstones. That is what we refer to as hailstones, these individuals. And the condition which is created around, that is what is referred to as a hailstorm. The entire phenomena or the event, that is referred to as a hailstorm. So for that hailstorm to occur, you need both these conditions. If the cumulonimbus cloud would not have been present, the particles would not have had so much of throwing up and coming down. That would simply not be possible. So that is why you needed a cloud which was vertically very thick, and only cumulonimbus clouds fit the bill. Only there it is satisfied. So that is why cumulonimbus is a must. Second, intense low pressure. Because if there is no intense low pressure, the wind will not be rising up with such a great force. So here, that is why in most of the cases across the country, most of you recall since your childhood days, whenever you have observed this, right? Whenever you have observed this phenomena where you have ice particles falling, which many of us easily we mistake it for a snowfall, right? And we make that sturdy claims, and very proudly we claim that, you know, in Madhya Pradesh there was a snowfall and you did not know. In West Bengal there was a snowfall. In Andhra Pradesh there was a snowfall. What are you saying? Why are you saying people should go to Ladakh, Kashmir to visit snowfall? We have it in Hyderabad only. Why should we travel that much? It is not a snowfall, it is a hailstorm. And if you recall this, whenever this has happened, mostly you will observe that it occurs during the summer season in the afternoons, right? Generally, you will observe them to be happening across the afternoons or in the evening when there is that sudden cooling which is provided, due to which the larger particles, they start to drop out. But whenever you would have observed this, you would have observed there's a very strong wind movement, dusty weather conditions due to the strong wind movement that is created just prior to those hailstorms falling down. Only in certain areas of the country, that is in the region of Delhi, in the region surrounding Delhi, in the region around Rajasthan, northern Rajasthan, parts of Haryana, only in these areas we observe the rare occurrence of hailstorms during the winter months, that is during the month of December. Now, that also happens because of an intense low pressure and cumulonimbus cloud. But the low pressure created there is not because of thermal heating, is because of a traveling low pressure that when we come to Indian geography, we will be able to understand better when we study the realities of Western disturbance events and so on. We'll be able to understand that why and how can a low pressure condition exist during the winter months in the northern part of the country. So otherwise, in most of the parts of the country, you will experience this during the summer season, in the afternoon and in the evening. Okay. Generally does not occur over deserts. Generally, I'm saying, why it does not occur over deserts? Because over deserts, rarely will you come across the formation of a cumulonimbus cloud. Wherever in desert, even if you see some patches of cloud, either they are cirrus or cumulus in nature, small ones. You don't observe the cumulonimbus cloud formation. Okay. Pratyaksh, but how rainwater managed to come out defying the winds? That is why during hailstorm, when you have the rainfall which is observed, observe it carefully the next time that you experience it. It is not like your regular rainfall. You will find that suddenly the wind becomes so dominant that in a particular region, raindrops, they are coming, but they are flowing away somewhere. And then you have these massive chunks of ice which further predominate. So rainfall also gets dominated or influenced by this strong wind movement, but eventually an over surplus amount of water, they manage to overcome that wind movement and wind resistance, and that is when they fall in chunks blowing across with the wind, and that is the weather condition experienced. Okay. Now that is how we experience these hailstorms. And these are events, again, related to intense convection activity of that wind. So here you have the requirement of a very strong vertical movement of the air. And this strong vertical movement of the air, this is also what is referred to as updraft. Updraft of air or upward movement of air, that is what leads to hailstorms. This is a question we discussed yesterday, so I hope that this question is clear and need not be discussed again. Now we come to the types of rainfall that we experience overall across the globe. The types of rainfall that you experience anywhere across the globe, they can basically be summarized into three major events or three types of rainfall. Now, the type of rainfall is majorly classified based upon how this rainfall is happening or why this rainfall is happening. That is the criteria for defining the types. So when we say types of rainfall, we have a convectional rainfall, we have an orographic rainfall, and we have a cyclonic or a frontal rainfall. Now, convectional rainfall, the name in itself tells you that convectional means what? That this is a result of the process of convection, isn't it? So this is a result of the process of convection. Resultant of convection. Order of clouds is irrespective of height. Ranjan, that is present in the PPT itself. Look at the annotations of yesterday, you will find that. Preetham, why this portion includes in book? For you guys to study, that is why it is included in book. Do you want this portion to be removed from book? Kindly send a mail. Okay. That is why this is provided in the book for you guys to be able to study. So here, this convectional rainfall is a resultant of the process of convection. Convection is what? Where you have warm air which starts to rise up, that cools down, and eventually that heat is distributed. So this is something which happens on a daily basis, typically in the equatorial areas of the world. And why it happens on a daily basis is throughout the day, the sun shines and sun is able to heat up the water bodies, which will carry out increased rate of evaporation. And due to that increased rate of evaporation, more cloud formation will take place. So here, think about it. If I say that this is a place where you have water, etc., where they, through transpiration, through evaporation, water consistently goes up. Vertical movement of air and moisture laden winds happen. Which kind of cloud will you observe to be formed if this happens throughout the day when there is evaporation? Which kind of cloud do you think will be created? Beautiful, Pranay. Very good. Abhishek, wonderful. Sweetie, Seni, Gagan, Dinesh, Ayushman, very good. See, all those who are saying cumulus, you guys are not incorrect. You are simply inaccurate, right? So cumulus basically will be formed wherever there is evaporation which takes place. But because you have significant amount of evaporation which continues throughout the day, that is what leads to formation of cumulonimbus clouds. Leads to formation of cumulonimbus cloud. And whenever there is a cumulonimbus cloud, along with heavy rainfall, what are the other events that are associated with cumulonimbus cloud? What do you think? Beautiful. It is going to be accompanied by thunder and lightning. It will have thunder and lightning storms will be observed here. So, whenever you go to an area such as an island territory of sorts, right, especially during the rainy season, etc., there you observe the daily occurrence of this rainfall. Whenever you go to, let's say, the equatorial region, where on a daily basis water is lost due to evaporation, significant amount, it will form clouds. And there, naturally, in the region around equatorial area, we have the rising column of air, because we have seen that is the region of ITCZ. So you have the rising column of air. So that is why it is a very common event in the equatorial areas, in the maritime regions, regions near the water bodies. There you will observe daily evening rainfall, which occurs, modifying and moderating the temperature and the weather conditions on a daily basis. Then we have orographic or relief rainfall. What is it? So this is a rainfall which is a result of a physical barrier provided to the movement of the wind. So physical barrier provided to the wind movement. Now this physical barrier will be provided by what? By you and I. If tomorrow we decide that we are very strong, we are very powerful, we'll start going to the gym and all, so can we stop the wind movement by providing the physical barrier? No. These are provided by mountains, hills, and also in certain cases the sides of the plateaus. So those kind of physical barrier, they are able to provide this. So this is provided by the mountains, hills, not buildings. Buildings are also too small. In the larger scale of things, Prashant, building is absolutely a miniature form. So buildings, and especially when you talk about buildings present here or present anywhere in the globe, they are very small feature. The winds can easily go around them, right? So plateaus, etc. Okay, that is what provides the sudden upliftment of the wind. And whenever there is upliftment of the wind, there will be cooling and there will be subsequent cloud formation as well. Then we have the cyclonic or the frontal rainfall. Fronts are something that we have not yet covered till now. We will cover it today only. So you will have a better understanding of frontal rainfall when you read that. Having said that, Fronts we have seen during frontal inversion. What is front? When you have two different masses of air, that is cold air coming from one region, warm air coming from another region. Warm air tends to climb up. This is what is a front, and it is the rainfall which occurs here. So let us individually take a look at each one of them and let us try to understand what they are. Chinmay, when the mountainous area receives rainfall, will it cause landslides? If enough amount of rainfall, yes, easily. Why not provide this topic in Byju's book? See, my dear friend, there are many topics that we cover in the class which you will not find even in standard textbooks. And these topics keep on getting added, keep on getting removed. That is the purpose of you attending the live class, isn't it? Otherwise, if everything is in the book, all you need is an audio story, somebody to simply read out what is present in the book. Why do you need to attend the class? The purpose of live class is to bring about the concepts in a holistic manner, so that after this, once you are able to relate to all these, you are able to paint a larger, better picture. That is why, again, further again, as we move ahead, you will find certain topics which are not present in the book. And these topics, they keep on getting updated year after year. So I think you have to make peace with that. So that is why pay attention in the class. That is the alternative that you have. Okay. So here, when we talk about convectional rainfall, convectional rainfall is basically a resultant of the vertical movement of the air in the form of evaporation, transpiration, all of that. Basically, they end up losing water into the atmosphere. These vapor, they go up, they lose temperature, become colder, they start to condense, form cumulonimbus cloud, and along with thunder and lightning, they bring evening rain. So it is a daily occurrence in evenings, afternoons, or evenings in equatorial areas, then island regions, coastal areas, etc. And leads to formation of cumulonimbus clouds, which is accompanied with thunder and lightning. With thunder and lightning. Okay. So if you get an opportunity to travel to Andamans or Lakshadweep or Maldives, especially during the month of May, June, etc., this is something you will observe on a daily basis. Similarly, in the coastal territories that you go, sometimes in certain coastline, especially across the island nations in general, you will experience daily occurrence of evening rainfall. So that rainfall will not continue for a very long time. That it has started raining at 2 p.m., it will continue to till 10 p.m. at night. No, it will start raining at around 4 5 p.m. It will be over by around 6 or 7. So 1 or 2 hours of intense rainfall at max. Why not more? Because the cloud has been formed there itself because of evaporation. So it does not have a built up content of vapor or built up portion of liquid droplets which are present. That is why you will receive restricted or limited rainfall in late afternoon or early evening. Okay. Now, then we have the orographic rainfall. Orographic rainfall, again, provided because of a physical barrier. Now, in India, significant amount of rainfall received throughout the country is a result of this orographic process or orographic factor. Now, when there is a physical barrier, this region of mountains or highlands or hills, all they provide is a physical barrier. Okay, so this is a physical barrier. That physical barrier, what it does is it provides or forces the wind to rise up. So it forces the wind to rise up. The wind to rise up. This is what is also referred to as orographic uplift. Okay. So here what happens, whenever a moisture laden wind approaches a mountainous area, whenever a moisture laden wind approaches a mountainous area, it is forced to rise up. As it is forced to rise up, it loses its temperature, cools down. Right? It cools down in the process. As it continues to rise up, it reaches saturation, cools down even further, and that is what leads to formation of clouds, and it will cause rainfall. In the case of the mountainous areas or the hilly areas, you will always find that rainfall is received on the windward side. Rainfall is always received on the windward side. And on the leeward side, you have lack of rainfall. Lack of rains. Why? Because the air, yesterday also we had seen in the case of Chinook and Phone, that the air becomes dry by this time, and as it moves down, it undergoes an orographic or an adiabatic compression, it warms up, and that is why you have the dry descending air which is warmer on the other side. So that is where on the leeward side of the mountain always will have lack of rains. There will be no rainfall. So leeward side of the mountain will always have a condition of lack of rainfall. It will not receive rainfall because whatever rainfall had to be received was received by the windward side only. So this creates on the leeward side, the entire region is referred to as rain shadow zone. You can see here, rain shadow zone. So you don't receive rainfall. Take an example. When we talk about the Himalayas, now the southern portion of Himalayas, they experience, let's say, this is the alignment of Himalayas, the southern face of the Himalayas, they will consistently experience the orographic uplift provided to the monsoon winds. So on the southern slope, you will always have excess rainfall, but the northern slopes are drier. That is why the region of Ladakh, which lies beyond all the three ranges of Himalayas, that is why Ladakh is a dry desert almost. Because by the time that the winds go to the leeward side, they have already become drier. Right? So that is the reason why when you talk about the Western Ghats, the western part of the Western Ghats receive very heavy amount of rainfall. Some of the highest amount of rainfall received across the world. But when you come to the eastern part of the Western Ghats, that is in the region of eastern part of Maharashtra, the Vidarbha region of Maharashtra, Telangana, Uttar Kannada region, Andhra Pradesh. In all these areas, you will observe that the rainfall amount reduces. Why? Because whatever rainfall had to happen happened in the windward side. Leeward side, you have dry air because the air has been drenched out. It has been drained out. So that is what is rain shadow effect or the rain shadow region. Always, if the physical barrier is taller, it is higher, the rain shadow region will also be larger, because whatever rainfall had to happen, whatever little amount of moisture was there, that has been drained out. So always you will find, in case the hills are smaller, moist winds can sometimes pass those winds as well, pass those hills as well. But if the mountains, hills, they are taller, then the other side will definitely be dry, very dry. Okay, so that is basically the event of orographic rainfall. This is caused due to the physical barrier offered to the wind movement. Okay, lack of rain means it is not raining. Lack of rains is a very simple term, Preetham. Lack of rains means it is not raining in that region. And Biswajit, why there is adiabatic heating in the leeward side? Because Biswajit, observe here that the wind is coming from an area where the air density is low to an area where the air density is higher. So obviously, in order to accommodate in that region, they will have to compress themselves. That is why. Why thunder doesn't happen during hailstorm? It can happen, Rohan. Thunder can happen during hailstorms. There is no such rule that thunder will not happen. Why orographic rainfall is called relief rainfall? Devansh, the reason is very simple. When we say orographic, so all these features, they are referred to as relief features. So these are relief features. The topographic anomalies that you see, the topographic variations that you see, undulations that you see, they are referred to as relief features, right? That is why it is relief rainfall, not the relief that finally we have received rainfall, so there's a huge sense of relief. No, not that relief. It is a topographical relief feature, as it is referred to. Okay. Adeline, for why we do not get more rainfall at some areas of Tamil Nadu? See, the regional distribution of rainfall, that is something that you have to wait till we come to Indian geography. You have to understand why an area receives more rainfall. Before understanding why an area doesn't receive more rainfall, first of all, we'll try to find out solutions that why, for example, Cherrapunji and Mosinram, they receive the maximum amount of rainfall throughout the world. Why is it so? And still you have in the same country the presence of Thar Desert, which is dry. So first of all, let us go step by step. We will find the solution of it. Don't worry. Okay, and Nandamuri, will these winds cause increased dryness in these areas of descent? Absolutely. In the rain shadow zone? Perfect. Yes. What determines rain's direction? Wherever the cloud is, there only you will receive rainfall. Have you ever noticed that today the rainfall is coming horizontally? It will always fall vertically. So the sense of direction that you think about, I'm unable to get the question that the direction of rainfall. If you are asking that whether it is going to rain like this, or whether it is going to rain like this, or whether it is going to rain like this, if that is what you mean by asking the rainfall direction, this is determined by the wind movement on the ground. If the wind movement is in a certain direction, it will deviate the rains accordingly. Okay? Right? Yes, Devansh, that is correct. Now, we come to the frontal or cyclonic rainfall. So this happens when you have the interaction of when the cold and warm air mass interact with each other. each other. Now, in that case, what happens is they will form a zone of transition. They will form a zone of transition. Here you have cold air, and here you have the incoming warm air. This warm air will be forced to rise up. Now, observe this carefully. I will come back to this again as we move into the next module. I'll come back to this again. But by that point of time, if you have understood it once, it will always be beneficial to you. So, when we talk about it, for example, there is a warm air which is climbing up. So, let us consider any position here. Let us consider this position A. Now, here, warm air is in direct contact with the cold air. So warm air will cool down. When the warm air cools down to the level of saturation, and if the cold air is further cooler, warm air will cool down even further. So when that warm air cools beyond saturation, what will happen? You will observe the formation of a cloud here. So that is where in this region, you will be able to observe the formation of a cloud in this area, because the warm air is in contact with the cold region. So the warm air cools down, condenses, forms clouds, and that is where in this region you will experience rainfall. Or just so that you don't get confused with the direction, this rainfall can happen like this also. This rainfall can happen straight as well. Okay, so that is where rainfall doesn't have a direction, my dear friends. Wind has got a direction. Okay, so that is how the frontal cyclone, frontal rainfall does occur, where you have the creation of a front, the warm air climbs up, gets in contact with the cold air. As the warm air gets in contact, the warm air loses temperature, becomes colder, reaches saturation. Further cooling leads to condensation. Okay, so here, warm air cools, reaches saturation, forms clouds, causes rainfall. Okay, now this is generally observed in the mid-latitude areas of the world. Generally, when we talk about frontal cyclones, they occur in mid-latitude regions. Mid-latitude means 35 degree to 60 degree, or generally 40 to 60 degree. That is referred to as mid-latitude areas of the world. Okay, Rohan, cold air being heavier will be in down level and warm air will so. Yes, that is correct, Rohan. And Chinmay, is there any chance that desert will receive rainfall? Depends on which desert are we talking about, Chinmay. You have the Gobi Desert in Mongolia, which is famous for snowfall. So you have the cold deserts as well, you have the dry deserts as well. Ladakh, for example, is considered, many areas are considered to be cold desert. You have snowfall in those areas, but it is very restricted, very limited. Okay. Preetham, my dear friend, that is why I have answered your question particularly. If it is not in the book, kindly cover it from the class. Kindly look at the additional reading materials. That will be more than sufficient. Okay, you have pasted this question at least 50 times, and I have answered it before. I am answering it again. If this is not present in the book, that is why we have the live classes. Now we are providing the recording of the live classes as well. Refer to it, refer to the annotations of the PPT, refer to the additional reading materials. That shall be more than sufficient for your coverage. I hope that satisfies the query that you have been putting up. Okay. Shruti, in mains, the question from this portion, climatology, is very significantly present. And you have direct question from the static areas which are picked. We will be discussing the mains type question. We will get an idea about that. Okay. Now we come to fog. Fog and mist, they are also a kind of condensation which happens. They are also a resultant of the process of condensation. Let us be very clear. Now, when this is a resultant of condensation, why will the condensation happen? The condensation will happen when the warm air, which consists of water vapor, that comes in contact with any cold surface, loses its temperature and undergoes saturation, then further by condensation. So that cold surface with which the warm air has to come in contact, that can be wind, that can be the cold surface on the ground, or can be anything else. So that is where fog is a mere resultant of the process of condensation. The only difference between the cloud, which is also a resultant of condensation, and the fog, the mere difference is the fact that this is a process which happens closer to the ground surface. Clouds happen to form in upper altitude. Fog is formed on the ground surface. That is the only difference. Okay. Now, fog is a cloud with its base at or very near to the ground, a cloud or a cloud that touches the ground. So fog shows up when water vapor of water in its gaseous form condenses. Why will it condense? When it comes in contact with a cold surface. When it comes in contact with cold surface. So this is, as the definition says, this is like a cloud formed on the ground. The only difference being that in the cloud, the condensation happens at a higher altitude. And in the case of fog, the condensation happens near the ground surface. That is the only existent difference in between them. Now then you have another event, that is mist. Right? Mist is also a resultant of the process of condensation, formed in a very similar manner as that of a fog. The difference between fog and mist is in terms of the size of the droplets which are created. That is it. The size of the condensate liquid droplets which are created. So here, the only difference between mist and fog is that mist contains more moisture than fog. Why? Because in mist, each nuclei consists of a thicker layer of moisture. That is, each of the droplets that you observe, they are slightly larger. In that case, a mist is formed, otherwise, fog is created. Okay? Let us now take a look at now, by the way, no question will be asked in examination that write the differences between clouds and fog, write the differences between mist and fog. These are the questions which are asked up till your class 8th level, or maybe nowadays till 10th level. So that kind of a question, please don't expect that. Difference, write the difference. That kind of a question does not or is not asked. All that you need to know is that in the case of a mist, the size of the droplets are larger. That is why in that cumulative area, there will be more moisture which will be felt as a result of that condensate. Okay. Now, when we talk about fog, you have different types of fog. You have the radiation fog, advection fog, upslope or orographic fog. Then you have the steam fog, which is one of the most visually appealing fogs that you will come across in a way. Then you also have the valley fog. Now, in all of this, the event or the process which is creating this fog, the process is the same. What is the process? In all of this, the process is that you have the warmer air getting in contact with the colder air or the colder surface, undergoing condensation. That is it. In all of them, the process is the same. How they are formed or when is it that this process unfolds, that is the basis on which they are classified into different categories. One by one, we'll take a look at each one of them. We'll try to understand where they are formed in general, and that will be able to clarify many things. So here we start with radiation fog. Now, in order to understand radiation fog, I want you to recall from the back of your mind in some section where you store things. So, we had studied the portion of surface inversion, if you recall. We had studied what that surface inversion is. We had studied that surface inversion is created when the surface loses heat due to terrestrial radiation, right? We had seen that. Something very similar happens here as well. In the case of the radiation fog, first of all, surface becomes very cold during night. Why? Because, or how? By losing heat through terrestrial radiation. And then after that, air in contact also becomes very cold. Now, this air in contact, which becomes very cold, now that air will lose heat, reach saturation, and also undergo condensation. Undergoes condensation. Now, here, think about it and think about it for some time, that how is it that these conditions can unfold? During what scenario or what situation will we have these conditions which will unfold? So, one by one, the conditions required. This is where prelims questions are framed from. That what are the conditions required for this or that? Conditions required. One by one, we'll take it up. So, during which season of the year do you think that this will occur? The loss of heat will be significant. During which season? Winter. Beautiful. Winter, you have long nights. During the winter season, allowing more heat to be lost by terrestrial radiation, right? So that is where the surface will become much colder. Now, will the cloud cover facilitate the formation of this fog, or will the cloud cover discourage the formation of this fog? What do you think? How will the cloud cover come into play? Do you need cloud cover for this, or do you need clear sky? Beautiful. So you need clear sky. Why? This was a question that UPSC had asked in the prelims, that why during cloudy nights we don't experience fog formation. And the reason was very simple, that when you have the presence of clouds, the clouds will re-radiate back the terrestrial radiation. That is what creates warmer conditions on the ground. That is why cloudy nights are warmer as compared to clear nights. Now, about the wind movement. Do you think that you need a strong wind movement for the formation of this kind of a fog? Or do you need a weaker wind movement, or you need absolute calm conditions and lack of wind movement? What do you think? Very good. So you need calm conditions. That is lack of wind. See, all of you guys are able to decipher these conditions on your own. That is the approach which is needed for the exam. If you develop this approach where you know a particular event and you are able to think about the conditions, you might be slightly incorrect in many of the cases, but eventually if you are able to look at the larger picture, that why this is happening, that is more than sufficient to tackle the conceptual questions in prelims and the twisted question that UPSC asks in the mains examination. That is the frame of mind I need you guys to be in, where you attack the question rather than being on the defensive that, okay, I don't know why this has happened, I have not read it somewhere. Fair enough, you have not read it somewhere, but apply your mind there itself, that why that could happen. Why is it that vertical updraft of wind is present? There must be a low pressure somewhere. So those conditions need to be applied naturally. That is how the subject will come to you. Okay. Now here, if we take a look at the event of the formation, so during night time, the ground loses heat, and the ground loses heat with the help of terrestrial radiation. Terrestrial radiation. It is due to this terrestrial radiation that the ground loses heat. Now, eventually, if the nights are long, cold, they don't have cloud cover, so this loss of heat will continue. And that is when the ground becomes very cold. Now, the air which is in contact, let's assume this is the air in contact. So this air which is in contact, that air will also start losing temperature, becomes cold, reaches saturation, and thereby leads to condensation. So across the northern part of the country particularly, during the winter season, you experience this fog to be created and this fog to be formed. Across majority of the parts of the northern India, you will observe this fog to be created during winter months. Now, here in southern part of the country, in many parts of southern India, across the hill stations, etc., you'll find this event when the region becomes colder, particularly after a lot of rain, when it suddenly becomes cold, when the conditions become cold. So that is when you observe this. So here, once the fog is created, how will it dissipate? How will it disappear? So the next morning, when the sun rises up, in the early hours around 5 a.m., 6 a.m., you won't be able to see anything because there will be a thick blanket of fog. But then as the sun starts to rise up, by around 6 a.m., 6:30 a.m., the sun has risen up. Now, once the sun rises up, now that will provide heat to the ground surface. That will heat up the ground surface. So the ground surface gets heated up. When the ground surface gets heated up, what will be the outcome? What will be the resultant? The air immediately above it, that will start receiving the heat. Now, when the air starts receiving the heat, what will happen to its carrying capacity? When the air starts receiving the heat, what will happen to its carrying capacity? It will increase, isn't it? This is something which will increase. So that is when the carrying capacity increases, and whatever condensation would have happened due to saturation of air, that is reverted back. That entire scenario is reverted back, and the fog dissipates from the lower portion up. So this fog dissipates. Dissipates means disappears from the ground upwards. The fog starts to disappear from the ground upwards. That is always the phenomena. Okay. Now, terrestrial radiation we have already read in the 6th module, and we have spent a lot of time in that, Arindam. Kindly look at the annotations of the PPT in greater detail. It is the heat given out by the surface of the earth after it gets heated. Kindly look at the annotations of the previous module, right? That is why I say please try to revise the portions that we have covered. This is not one of those subjects where suddenly after 3 classes I will attend and what is there, I will read something new. There is an intricate linkage from the previous concepts that helps you build the newer concepts. Kindly revise. Then we come to the advection fog. Now, this advection fog, when we say, this is basically created due to the advection process. Advection is what? Horizontal movement of air. So this is created due to horizontal wind movement. Horizontal wind movement. Okay. Now this horizontal movement, how can that induce a fog? So this will happen when there is a warm wind moving over a colder area, and that warm wind comes in contact with the colder surface. So the wind automatically starts losing temperature, becomes colder, becomes saturated, undergoes condensation. So here, warm winds move over colder regions, right? A kind of a warm advection of sorts. The wind gets colder, forms fog. So that is how you have the formation of advection fog. Generally, it is observed in the regions across middle latitudes, where you have warm tropical winds coming from the region of the subtropical high pressure belt. When these warm winds get in contact with the colder areas across Europe, across the region of North America, that is when they start undergoing that process of condensation. Okay. Land breeze and sea breeze directly they won't lead to the formation of this fog. Sometimes they can do, Molly, if there's a temperature difference which exists. But because in the case of land and sea breeze, most of this wind movement that you observe, that is temperature driven movement. So that is why there you don't come across such scenarios. However, if you have onshore and offshore winds between the pressure zones, whenever you have tropical air mass going to the colder areas, always you have the formation of this advection fog. Sometimes what happens, you have warm water of the ocean mixing with the cold water of the ocean coming from another region. So the wind above them, they also collide, and they also lead to the formation of fog in that region. So you will have warm water and cold water, so warm air and cold air, and they will mix. So the warm air will start undergoing condensation. So that also does happen over water body. Okay. Now, yes, Deepika, that is correct. Then we have steam fog. Steam fog, the name is given because it resembles the activities or events of a steam. When you see steam, steam is what? Steam is basically superheated water vapor which starts rising up. That is what is steam. So why is this fog referred to as a steam fog when we know that for the formation of this fog you need condensation to happen? So why does this happen? And where does this happen? So the name is given as steam fog based upon the appearance that it gives. If you look at the appearance of it, it will give you the appearance as if steam is rising from water, but it is not. Here, there is a movement of wind creating this. So what is happening here? So this is formed when you have cold and dry air moving over warm water bodies. So when will this happen? This will happen generally in colder regions at night time. That is when this will happen. In colder areas, during night. So colder areas during night and any colder area? No, wherever you have a water body nearby, only in those. Because when we say colder areas during night, land temperature, which will be colder during night, land or water? What do you think? Very good. Water is warmer and land is colder. Now here what happens is, for example, if I consider a land area and nearby you have a water body, let's say in a form of a very large lake, a very large pond, not a pond, a very large lake or a water body of sorts. Please don't try to associate it with your simple small with a smaller lake or pond that you would have seen in your village or in wherever you belong from. That there we don't observe it. Considerably larger area. So here what happens? Here during night time or early in the morning, generally when it is observed. Now water is comparatively warmer, land is colder, water is warmer. Now, this water, will it experience evaporation or not? What do you think? Will it experience evaporation? Perfect. It will experience evaporation. So due to evaporation, water vapor will try to rise up. Evaporation. That means in the air immediately above it, you will have the presence of water vapor as rising columns. This water vapor as rising columns. Okay. That is something you will find all across. Now, here this is your water vapor. Now, in the meanwhile, from the land area, which is colder, you will observe the driving of cold winds over the warmer region. So, cold winds will come. These cold winds, when they interact with this water vapor, what do you think will happen? The water vapor will lose temperature, the air will reach saturation, and it will lead to the formation of fog, isn't it? So, when the cold winds get in contact, so these cold winds, they will lead to condensation in this entire region and they will give you the appearance as rising columns. This is nothing but the water vapor which has been condensed. Condensation of water vapor. So because it will give you an appearance as if there are rising columns of steam of sort, that is why it is referred to as a steam fog. Let me recap this process. So this happens to, or this takes place, or this is something which unfolds in colder areas during night time where you have land and water. Now, water is comparatively warmer as compared to land. So water is the region where the winds will be moving to. right? Now, above that water, you will have evaporation. Other than the polar areas, you consistently experience evaporation across the planet. So, evaporation will happen. Now, that vapor, as it is rising up from the water, it will experience a cool blast of wind coming from the land area. So, that cold wind will lower the temperature, take or lead to the formation of fog, and which that fog will appear as rising columns, hence they are referred to as steam fog. This is generally observed in areas where you have, for example, you have the mountainous region, and in between the mountains you have a large lake. For example, even in Nainital, sometimes you observe this steam fog. Then, for example, such kinds of areas, Wayanad in Kerala, you will observe the steam fog. So, but other than that, in colder areas, in mid latitudes, etc., you will always be able to experience this steam fog. Okay. Yes, Bimal, it will take place in the Caspian also. It is a kind of Shamil. Yes, we can say that it is a kind of advection fog, but it is more specialized over land water boundary itself. Okay. Now, then we come to upslope fog. Upslope fog is basically a fog condition formed when the winds move upwards in a slope. So here, the winds, if the winds move upwards in a slope, they can form clouds also. So why is it that here we don't observe the clouds? So these are where you have the gradient which is slightly gentle. It is not very steep. So you have the gentle gradient. Gentle gradient and very slow moving air. Very slow moving air. Now, this slow moving air, as it rises up, it will lose temperature there itself in the process. So here you will observe that as the air is moving very slowly across the slopes, it will experience a kind of a condensation, and you will have the formation of a fog in that case. So upslope fog or hill fog forms when winds blow air up a slope, which is also referred to as orographic uplift. So in that case, you will observe the formation of a fog in that case. Okay, so this is observed in hills, in mountainous regions. Whenever those of you who go to the mountains for trekking, for adventure purposes, early in the morning, you will observe this. Okay, then we come to what is referred to as valley fog. Now, this valley fog is created because of the reasons which is very similar to the creation of valley inversion, if you recall. You recall that we had studied valley inversion in significant detail. So the reasons are almost similar. So here, if we talk about it, let's suppose mountainous area, and this is the valley bottom. Now, during night, what happens? Mountain tops become very cold, right? We know that cold air is heavy. Cold air is very heavy, we know that. And it sinks to the valley bottom. While it sinks to the valley bottom, it displaces the warm air. And when the warm air is displaced, warm air, due to contact with cold air forms fog. So, for example, as has already been written here now, the cold air which is present on top of the mountain during night time, the cold air will start sinking down. Cold air will start sinking down. Now, as this cold air starts sinking down, whatever warm air was there at the valley bottom, that will be easily uplifted by the cold air. So, at the valley bottom, while we experience the conditions of valley inversion, but the warm air which has been lifted up, let's say we give this as the warm air. Section of warm air. Now, this warm air gets in contact with the cold air, and that is why across the valley you have the formation of the fog. That is where the entire valley becomes invisible during late at night and early in the morning. Again, when the sun starts to shine, the valley bottom will be heated up, and that is when the fog will dissipate. So, that is how you have the condition of or the creation of valley fog. Okay. Now, after this, a couple of questions which have appeared. So, I'll give you 30-second time. What causes the wind to deflect to the left in southern hemisphere? All of you kindly try to write the answer. Kindly try to solve it. I expect maximum of you to give the correct answer in this. Beautiful. So why is it that the wind deflects? The wind deflects because of Coriolis force. And why is it that the Coriolis force acts? The Coriolis force acts because of rotation of Earth. Rotation of Earth. So this is one of the simplest questions that UPSC asks in the prelims examination. Then, westerlies in the southern hemisphere are stronger and persistent than in the northern hemisphere. Why? Southern hemisphere has less landmass as compared to northern hemisphere. Coriolis force is higher in the southern hemisphere as compared to the northern hemisphere. So what do you think is the answer in this? Nitesh, does it give you a sense of competition or a sense of satisfaction? So let's not indulge ourselves in that. So why is it that westerlies in the southern hemisphere, they are stronger? Beautiful. So here, southern hemisphere has less land mass as compared to the northern hemisphere, means more areas under sea, underwater body. More areas under sea means greater movement of wind because of less frictional force. So that is correct. Coriolis force is higher in the southern hemisphere. Absolutely not. This is incorrect. Coriolis force is equal in both the hemispheres. So the correct answer will be A1 only. Then, a layer in the atmosphere called the ionosphere facilitates radio communication. Why? The presence of ozone causes the reflection of radio waves to Earth. Radio waves have a very long wavelength. Why is it that ionosphere facilitates radio communication? So majority of you have given the incorrect answer in this. Well done. So here, as I was telling you earlier, now you want to see the leaderboard. So I can show you the leaderboard if you want now. Okay. This is the leaderboard. Only these many have managed to give the correct answer. So here, let us take a look at why you have marked it incorrectly. Most of you have marked it incorrectly because you marked what you knew rather than what the question is asking. So first of all, read the question carefully. A layer in the atmosphere called ionosphere facilitates radio communication. Why? So here the examiner is asking you about the properties of ionosphere. Why is it that ionosphere facilitates radio communication and not stratosphere, not ozonosphere, not mesosphere, not anyone else? Why does ionosphere facilitate radio communication? Because it has got presence of ions. Presence of ions, isn't it? Now, when you have presence of ions, that is what will reflect the radio waves. So, the presence of ozone causes the reflection of radio waves to Earth. Is the ozone layer present in ionosphere? Absolutely not. Incorrect. Radio waves have a very long wavelength, regardless of long wavelength or short wavelength. Now, if wavelength would have been a factor for the communication or facilitating radio communication, why would it have reached the region of ionosphere in the first place? It is purely driven by the presence of ions. So, the answer is neither one nor two. Okay. Now, the last question that we will discuss. The jet aircraft very smoothly or flies very smoothly in the lower stratosphere. What could be the appropriate explanation? There are no clouds of water vapor in the lower stratosphere. There are no vertical winds in the lower stratosphere. So, which of these are the reasons? This was also one of the questions which was contested by the candidates after the examination, but UPSC came up with the key and that gave us the answer. So, we will be following that answer only. And good to know that majority of you have given that answer already. So there are no clouds of water vapor in the lower stratosphere. Most of them you will find in the region of troposphere. So that is why this has been deemed to be correct. This is where it was controversial, because you have certain regions where you have the polar stratospheric clouds, etc. But then that was not an argument considered by UPSC. UPSC considers that all the water vapor is present in troposphere. There are no vertical wind movement in the lower stratosphere. That is again correct. So here you have the answer as C, both 1 and 2, even though the first statement or the first option statement is slightly contentious, but still, because UPSC has said C, so we will take C. So that is where we'll take a break now. And after the break, we'll start with the portion of air masses and cyclones. So let's take a break, guys, and we'll take a 10 minutes break. Okay. Let's take a 10 minutes break and let's be back and we will initiate the discussion here. A confirmation regarding the audio, please. If you're able to hear me out. Thank you. Now, one announcement before we proceed further, that from today onwards, now that we have entered into the holy month of Ramadan, so we will be having the break at around 6:30 or 6:40, depending upon the iftar timings of the day. So we will be having those 10 to 15 minutes break around 6:32 to 6:40, depending upon the iftar timings of the day. So from today onwards, we'll be having the break at that point of time. Okay. Now, and the good wishes to all of you who are celebrating the festival. So, a couple of questions. Why fog lasts for several hours? Biswajit, that is primarily because unless and until that heating is not provided. So, that heating sometimes is also blocked because you might have the formation of fog the previous night, and the next morning you might observe the existence of cloud cover. So, there is that heating which is interrupted. Okay. Right. And Rohan, is handwriting important for mains? To some extent, it is. And there is no denying the fact that if you have a good handwriting, compared to an individual who has a poor handwriting and the same level of content, you will always be given a bit more marks. So that is because your answers become legible. The evaluator is able to read what you have written, and it also creates a very good impression on the evaluator. So a good handwriting doesn't hurt. Okay. Pratyaksh, during valley fog, some radiation fog will be generated over the hills also. Yes, but will come down along with the winds in the valley. So you don't have that much amount. See, during the conditions of a valley fog, as the top of the mountain loses heat, the cold air immediately starts its movement downwards. That is where you will observe the majority of the fog formation in the valleys. Having said that, on top of the mountain also, you will have the visibility restricted because there also you have cold conditions which are prevalent. So yes, on top you will have that condition. And Devansh, in case of advection fog, warm air moves to cold air, but air always moves from a high pressure to low pressure. That is correct. Air always moves from high pressure to low pressure. But again, you have to understand that the pressure is not always dependent on temperature. You also have the dynamic pressure, the portions of the pressure that we are going to deal with now. So you also have the existence of dynamic pressure conditions. So there you don't have that situation. Um, Neil, yes. Ahmedabad, I told you, from today onwards, today in many parts of the country, just now one of you had also said that there is observance of hailstorm in some parts of Tamil Nadu and Kerala as well. And it is in Ahmedabad as well. So for the next 2 to 3 days, many portions of the country, we expect the occurrence of hailstorms because of extreme low pressure condition created. Because for the previous few of or the for the past month, you would have observed the increased amount of heating that the region has received. That is what has created that very intense low pressure. Okay. Now, after this, we come to the portion of air masses and cyclones. Very, very important for your examination, both for your prelims as well as for your mains. So in this, what is it that we are going to cover? In this, first of all, we are going to cover the concept of what do we mean by an air mass. Then, concept of source region. Source regions. Then, front. Types of front. of front, associated weather conditions, weather conditions. Then after that, cyclones, cyclonic and anticyclonic circulation. What is it? Circulation. Then after that, frontal cyclone, right? Or extratropical cyclone, its formation, properties. Then tropical cyclone, the cyclone which influences us all in India, formation. Now for the prelims perspective, you will find the important properties of all of them. They are relevant for your prelims perspective. Properties and features, associated features. That is something you'll find to be relevant in your prelims examination. And in the mains, UPSC frequently asks you questions from this area. So, air masses and influence on climate. Then, types of front. Then, tropical cyclone in general. Tropical cyclone. How is it that we go for the naming of the cyclone? Naming of cyclone. And also, even though the probability is less, but still you can expect a question from the frontal or the temperate cyclone. Temperate cyclone or frontal cyclone. Now, this is something which is most important for your examination, right? Tropical cyclone and its formation, that is, and its naming, that is going to be most important. This is one of those areas that UPSC does not hesitate to repeat the question from this area. Basically, you will find that some of the areas UPSC does not repeat the question, but there are certain areas in geography where UPSC has got no such reservations. It keeps on repeating the same questions, both in the portion of the optional part of geography as well as in the mains general studies portion of geography. You'll find frequent emergence of these kinds of questions. For example, in geomorphology, we had looked at a question of the Pacific Ring of Fire. Frequently questions are asked from there year after year. Similarly, in this portion, frequently tropical cyclone, its formation, its properties are asked. So these are the areas which UPSC tends to frequent. Okay. Now, when we talk about the air masses, what do we mean by them? Air mass. Now, remember what I told you, that how do we understand any concept of geography or any terminology of geography? I had given you a simple key. That is, look at the English meaning of it, the English translation of it. And that is something which is more than sufficient for understanding the concept in many of the cases. Air mass. That is a mass of air. So, what mass of air? In a room that you are sitting in right now. Now, can that be considered to be an air mass? No. So when we talk about the mass of air, then the room that you are sitting in, the room that I'm standing in, that will also have air. But why don't we consider this as an air mass? Because These represent large swaths or large areas of air where and large volumes of air, rather that volume is much more appropriate. So they include large volumes of air or large masses of air which can spread across hundreds and thousands of kilometers, as long as the air has got a homogeneous property of temperature and moisture and pressure. As long as the air indicates a uniform property of temperature, pressure, and moisture, that entire mass of air can be considered as an air mass. Think about it. When you go to the region of, if ever you have been to an area such as Leh Ladakh, or even, let's say, Rajasthan. Now, the air that you experience, let's take the case of Rajasthan. The air that you experience around you, that air will be very dry, right? It will be very warm as well. So dry and warm, it is a definitive property of temperature as well as the moisture conditions. Now, if you go to Goa or nearby Gujarat coastline, the air will be warm, but it will not be dry. It will be very moist. Why? Because it is closer to the coastal area. That is why there will be moisture. So this has got a different property. So within the same country, for example, if you consider the region of Leh and Ladakh, the air will be very dry, devoid of moisture, because it is lying on the leeward side of the three ranges of Himalayas. So by the time that air manages to reach up till Ladakh, all its moisture has been drained out. So the air will be very dry, but it will be cold. So here you have in Ladakh cold air, which is dry, Rajasthan warm air, which is dry. In the region of Punjab, maybe some moisture, very little moisture, slightly greater than in Rajasthan. As you move towards the region of Arabian Sea or Bay of Bengal, the air will start becoming more and more moist. By the time you reach Kolkata or Mumbai, air will be very moist. So in the same country, you have multiple different properties indicated by the air parcels present over them. So that is why across the entirety of the country, we cannot say that we have the existence of one type of an air mass. But on the other hand, take the case of equatorial Pacific. Now, equatorial Pacific is a very large ocean, the largest ocean. Now, equatorial Pacific, that entire region, it will have warmer air, which will be very moist as well. So, air, on whichever region that air is lying upon, on whichever surface you find the existence of air, the air takes the properties of that surface in itself. That surface from which air gains its properties, that is what is also referred to as the source region of the air mass. So, the air with distinctive characteristics in terms of temperature and humidity, that is called as an air mass. Now, when the air does remain over a region, a homogeneous kind of a region, the similarity in ground conditions, the similarity over in water bodies, etc. So when the air manages to remain over an area, a homogeneous area, for sufficiently longer period of time, the air gains the property and characteristics of that area. And that area is referred to as the source region. So here you see three different images. Now, just by taking a look at these images, we can have an idea about the property of the air here. For example, over this region, if I were to tell you the property, I can say roughly that the air will be very warm and the air will be very dry at the same time. I can talk about that, isn't it? It will be very warm, it will be very dry. Now, over this area, it represents a kind of a tropical water condition. Air will be warm, but it will be very moist. This area, frozen region, air will be very cold, some amount of moisture because it is over a water body. So these are your source regions, which give that property to the air. After air spends some amount of time over these regions, that is when the air gains these properties. So here, when we talk about the source region, The areas over which air masses originate or form, they are called the source regions. And the source region's property, nature, in terms of temperature, moisture content, largely determine the temperature and moisture characteristics of the air masses. So till now, what is it that we have seen? Masses of air are called air masses. They gain the property of the surface on which they lie. But what are these? Across the planet, if I have to think about it, what are these air masses? So now let us take a look at the major air masses across the globe. That will give you some idea that what do we really talk about when we say air masses, right? So here, when we talk about it, before that, how do we name these air masses, or how are these large air columns, how is it that naming is done? So any air mass, large air mass, which can spread over hundreds or thousands of kilometers because they have a similar property, any such air parcel, first of all, the naming is done with the basis of M or C. M represents an air parcel which is present over the water body, that is maritime, and C represents the air parcel which is over a land area, continental. So obviously, maritime air masses will always be more moist. Continental air masses won't be so moist, right? Then depending upon where is it that you find these, where is it that these air masses are found? So for example, here you can see the nomenclature. If it is found in the region of Arctic, a symbol A is used. A is used. If we talk about the region of Antarctica, Arctic and Antarctica, they are different in terms of their properties, and we have discussed about that. When we say the region of Antarctica, it is a continental area on which you have ice. Arctic, on the other hand, is a water body on which you have ice. So there is a subtle difference which is present. Then over the region of Antarctica, you will find double A, right? That is the nomenclature which is used. So the air mass which is present over Antarctica, how will you name it? Antarctica is a continent, so you have CAA. The region over Arctic, how would you name it? Even though Arctic is a maritime area, but surrounding it you have closed land masses, and it represents a continental feature in many of the cases. So you will name this as CA. Then if you consider the continents and oceans in the latitude of 50 degree to 60 degree north and south, you attach the term P, polar. If we talk about the continents and oceans at 20 to 35 degree north and south, you attach the term T, tropical. And then you have equatorial represented by E. So all these, now in the case of E, you observe it represents oceans close to equator. So you will find ME, maritime equatorial, but you will not find the existence of CE. CE as an air parcel does not exist. There is no continental equatorial. There is no continental equatorial air mass. Now, what can be the reason for this? We'll come back to it. But first of all, let me show you what these air masses are. So overall, you will take a look at it, and if you observe it, first of all, the equator. So let us demarcate the equator. This is the equator. Now here observe that closer to the equator, water bodies, wherever you have the water bodies, you have maritime equatorial, ME, maritime equatorial, right? So maritime equatorial is present. Then as you move away from equator, you come to the tropical region. That is the Tropic of Cancer in the north and Tropic of Capricorn in the south. So you will have tropical conditions. If the air is over continents, continental tropical. If the air is over water body, maritime tropical. So maritime tropical, continental tropical. Observe here. maritime tropical, maritime tropical, right? Maritime tropical, both in the northern and the southern hemisphere, maritime tropical. And the continental area is continental tropical, continental tropical. Here also you will have some sections experiencing continental tropical. Here also, here also, right? Then further north, around 50 degrees, 60 degrees that you go, maritime polar, maritime polar, maritime polar, maritime polar. Now, when you go to the land areas at this region, 50 degree, 60 degree, you have continental polar, right? Here also you have continental polar. Then you have continental Arctic, this region, continental Arctic. Here, continental Antarctic. So these are your broader classification of the air masses. But here you will find ME or CE is not present. You won't find the existence of CE. Why? Think about it. First of all, take a look at the region of equator here. Now, at the region of equator, do you find the continental land masses to exist? Yes, we do. Where? In this small area and in this small area. That's it. That is where you find the existence of continents. You have the islands here, but they will largely represent the maritime characteristics because you have islands surrounded by water. So maritime air will be very dominant. So you have very limited continental air, right? So if we talk about it, then lack of significant continental areas around equator. And also, if someone asks you that in this region of Brazil or in the region of Africa where the equator passes through, what will be the conditions or characteristics of air mass? Will we be able to provide a distinct answer? No, because the moisture is present, but the moisture is not dominant throughout. Just because the region is at equator, and if that region is devoid of moisture, does not mean that the air will be moist. And also, it largely depends upon the topographical realities of the place, that what kind of ground conditions do you experience there. So that is why if the equatorial land areas would have spread over larger regions, you could have the air being able to gain a kind of a homogeneous property. But in this, the land is restricted to a very small area. So the air is unable to gain a distinctive characteristic over this area. So air is unable to gain a distinct characteristic over this region. This region. Okay. So that is the characteristic or the feature that you associate with the air masses. So these are your major air masses. Now, the impact of air masses, when we say, what is the impact created by these air masses on local climate, on the conditions? So whenever you will have, let's say, a polar air mass coming into warmer region, it will lower the temperature, isn't it? Because it is cold. Whenever you have tropical air mass moving to polar area, It will warm up the region, warm convection. Furthermore, if you have a maritime air mass which enters into continent, these will be onshore winds, will bring rainfall. Continental air mass, if it moves over a land area, it will provide dry conditions. So the air masses, depending upon what are the features that they hold, they will have the distinct characteristic of what? They will have the distinct characteristic of temperature and moisture. Right? So because of their distinct characteristics of moisture and temperature, they are able to influence the temperature conditions and the humidity conditions of any particular region. They can create heating and cooling, warming, and in a way, they can bring rainfall as well. So as of now, based upon what we have studied, can cause the air masses can cause heating or cooling depending upon what kind of advection it is talking about. Heating or cooling. It can also cause can lead to rainfall. Right? Now, these air parcels, they are present or they gain a characteristic depending upon the characteristic of the land there. They can be warm, they can be cold, etc. We have also seen earlier, while we were looking at the tricellular model of atmospheric circulation, that when you have two different air masses having distinctive properties, when they meet, they form what we refer to as a front. So the next thing that we are going to look into is fronts. What are these fronts? When you hear this term front, what do we mean by that? So front, in general, when it is used in your English language, how is this term used? The general led the battle from the front, right? The army is deployed at the front, right? So wherever you see the term front, it basically means the end portion of something or the leading portion of something, isn't it? So this is represented here as well. How? So when we talk about it, let's consider the ground surface. Now, cold air, let's say you have cold air, and then you have massive warm air. Now, we know that warm air will have much greater volume as compared to cold air. Cold air will be pretty compressed because of the cold conditions, and it will have a very restricted volume. Warm air will be expansive because of high amount of energy. Particles will keep on rushing here and there. Now, when they meet, what will happen? Ideal common sense tells us that when they will meet, the air, because they are so friendly with each other, they will intermingle, have a good time, and you will have a homogeneous mixture at the end of it. But that does not happen. It is not as if when two different air parcels will meet, they will become friends and everything will be hunky-dory, and you will have one is very cold, one is very warm, so you will have a resultant temperature in between. No. The cold air will have its own distinct property of pressure, its own distinctive property of temperature, its own distinctive property of vapor presence as well. Similar is the case with warm air as well. So when they come head to head or face to face, they will not intermix. Rather, they will form a zone of transition that is referred to as a front. So they will create a zone of transition, that is referred to as a front. On one side, you will have cold air. Other side, you will have warmer air. Okay, so this is the zone of transition. So when we talk about fronts, when two different air masses meet, the boundary zone between them, that is referred to as front. Two different air masses which should have different temperature and moisture conditions. The process of formation of a front or generation of a front, that is referred to as frontogenesis. Genesis means birth of something. So when we say frontogenesis, that loosely translates into birth of a front or generation of a front. So the process of formation of the front, when the cold air and the warm air actually meet and interact, that is referred to as frontogenesis. Okay? Now, the fronts, they occur in middle latitudes in general, around 40 to 60 degrees north and south of equator, and are characterized by steep gradient of temperature and pressure. So from one end of the front, if you manage to go to the other end, right? From one end, if you manage to go to the other end, you will experience significant change in temperature conditions as well as the pressure conditions. So across the front, that changes. Now, depending upon which of this air or wind is more powerful, whether it is the warm air proceeding into the cold air area, whether it is the cold air moving into the warm air territory, depending upon which of them is more powerful, that is how you have the classification of the front. Okay, so when we talk about types of front, you have different types of front completely based upon how is it that the air behaves within them. Okay, now where across the planet do you observe the formation of these fronts? Where across the planet do you observe this? So around the region of equator, let us analyze each area: equatorial area, tropical area, polar area. Around the region of equator, which winds are present? Which kind of winds are present around equatorial area? We have the warm tropical winds. So here also warm tropical winds, they come in. Here also warm tropical winds, they come in at the region of ITCZ. So will that create a kind of a front? No. Both of them have similar characteristics. So that is why no front. Then when we talk about, let's say, 30-degree north and 30-degree south. Now at 30-degree, you have air mass which is moving towards the, or wind which is moving towards the equator, and wind which is moving towards the subpolar area. But the wind is being generated, it is the same wind which is directed towards the equator and the same wind which is directed towards the subpolar area. So will there be a formation of front here? No. But then when we talk about subpolar region, here you experience cold winds coming from the region of the poles, polar easterlies. Here also you'll find the presence of polar easterlies, which brings cold winds from the polar area. Now that cold wind, it faces up or interacts with the warm winds being brought about from the 30 degrees, the westerlies. So that is where you will observe the formation of front here. You will observe the formation of a kind of a front here as well. So this is also what is referred to as, in many of the cases, as the polar front. Polar front. Absolutely correct, Preetham. Beautiful. This is what is polar front. Now this polar front, will it always remain static in that area? No. the pressure belts shift. So with the shifting of the pressure belts, this front also shifts. So in certain seasons, you will find that the polar front can come up till here or even northward. Similarly here also. So overall, now if I take you back to the image of this air mass here, if I take you back to this image here, I want you to look into the transition between the warm air and the cold air mass. Where is it that frontal formation will be observed? Observe here. This is the zone of transition. This is the zone of transition. So from this, we have another thing that we can extract from this. And that is the simple fact that this front is not a straight line. You have areas where the warm air rushes in, the warm air pushes in, and subsequently you also have areas where the cold air starts to come down, right? We have seen yesterday the case of blizzard. Remember when we looked at the local wind and we studied blizzard? What is it that we looked into blizzard? You have cold polar winds which come further towards the lower latitude. That is what is a blizzard, isn't it? Cold polar winds which start moving downwards. So that is the cold air pushing here. So that is why these fronts, they are never going to be static. They are always, in most of the cases, they are going to move because of the impact of either the warm air or the impact of the cold air. Let us take a look at the different types of fronts which exist. So you have the stationary front, the cold front, the warm front, and the occluded front. So for this, I will take the help of a couple of pages. For easier understanding, I will take the help of these pages to understand how the front actually ends up behaving. So stationary front. The name in itself tells us something which is static, something which is stationary at one place. It is not mobile, it is not moving, right? Then you have the cold front. In this, cold air is more powerful. Warm front. In this case, warm air is dominant. And then you have the occluded front. This is when, or rather, formed when the front is closed from behind. Okay? We'll take a look at each one of them, what they are, starting with stationary front. Giriraj, winds move from low pressure to high pressure. Then why trade winds are moving in opposite direction? That is high pressure to low pressure. My dear friend, your basic assumption that you have made, that is incorrect. Winds will always blow from a high to a low. Low pressure is not the region which generates winds. Low pressure is the region which attracts winds. So always remember this, winds will always blow from a high to a low. That is why trade winds, that is why westerlies, that is why polar easterlies, any wind that you take, you will never come across a scenario that it moves from low pressure to high pressure. In case you have any such wind in your mind which moves from low pressure to high pressure, please let me know. Okay? So we come to stationary front. Stationary, something which is static, something which is not moving, right? Now, why is this front created and when is this created? So this happens when the cold air is coming from the region of the polar area, the warm air is coming from the tropical area, and in their journey while they are covering, By the time that they come face to face and they form a front, they would have lost all their energy. They don't have energy anymore, which is left in them. So energy which is left anymore means neither the warm air is able to push into the colder territory, nor the colder air is able to push into warmer territory. So here it is formed when cold front or warm front stops moving. Or in other words, this happens when two masses of air are pushing against each other, but neither is powerful enough to move each other. So here, when we talk about, for example, let's suppose cold air has come from one region, warm air has come from another region. But then, after reaching there, none of them are able to move even an inch further because none of them have enough power, right? So, when they are unable to move, that is when the front is static. That is static. And that is stationary front. Stationary front. Now, in this stationary front, what can happen after the stationary front is created? So in this case, it might happen that over a period of time, that is 3 to 4 days, maybe the polar region becomes much colder and they start generating more cold winds. So in that case, the cold wind will start pushing and it will become a cold front. It might happen that the tropical high pressure becomes stronger and more warm winds come into place. That will be warm front. Or what can also happen is after around 2 weeks or 3 weeks, basically, it can also happen that this in the zone of transition, the air starts gaining properties from one another, right? It can also happen that the air, cold air becomes slightly warmer, warm air slightly becomes colder. So they start taking the properties from one region to the other. So when that happens, what will happen? Formation of a homogeneous region. And whenever there is a formation of a homogeneous region, that means there is no zone of transition anymore. So the front will come to an end. So it can happen that this stationary front gets converted into a cold or a warm front, or it might happen that the air gains each other's properties after 2 to 3 weeks and becomes homogeneous. That would mean death of a front. Okay, so here when we say stationary front can lead to formation of a cold or warm front, right? Or in certain cases, due to lack of movement for a long time, air gains the properties of other air mass. Whenever this will happen, this leads to death of a front. Death of a front. That death of a front or dissipation or disappearance of a front, that is something which is referred to as frontolysis. Frontolysis. So that is when the front ceases to be in existence because the air has now spent so much time around each other that they start gaining each other's properties. Now, in the meanwhile, while there is a stationary front, what are the weather conditions you will observe? You will observe the occurrence of a frontal rainfall here. So, first of all, frontal inversion, and also light frontal rainfall. Okay, light frontal rainfall, because none of these air masses, they are moving, they are static. Had they been moving, they could have caused heavy rainfall, but they are static. Okay, that is a stationary front. Now you have conditions where the cold front or the warm front, in each of the cases, one of the particular air masses that is more dominant. So we start with the cold front. So when we talk about a cold front, this is formed when it is the cold air mass which pushes into the region of the warmer air. It is a cold air mass. In one area, let's say you have the cold air, and another area, let's say you have the expansive warm air. So the cold air mass will push into the region of warm air mass. So what happens? So suppose, assume this. Assume this paper, I hope it is visible to you guys. I hope this paper is visible. So behind this paper, assume that this is the surface. Behind this paper, here you have the cold air. And on the other hand, you have the warm air. Let's say this pen represents the presence of warm air. And this paper represents the boundary of the cold air. Now we say that the cold air is advancing. The warm air is not. So when the cold air is advancing, it comes into the region of the warm air. What does it do? It suddenly pushes the warm air upwards. Suddenly. Suddenly there is a steep vertical movement of the warm air, isn't it? So when they come, basically, when this comes, it suddenly pushes the warm air above, right? So here, when they interact, uh, that pushes into a warm air mass, so significantly, or rather, the warm air is suddenly forced to rise. So there is a kind of a vertical movement of the warm air. Whenever there is a vertical movement, what kind of cloud formation would be observed in that case? When there is a sudden vertical movement of air, it will always lead to formation of cumulonimbus clouds. Perfect, very good. It will lead to the formation of cumulonimbus cloud. Why? Because the air will be raised up, will be pushed up. Some part will condense here, some part will condense higher, some part will condense higher. You will have the accumulation of a cumulonimbus cloud. So here, as the cold front pushes into, then the warm air, as you can see in the image, the warm air is suddenly pushed up. So due to this, there is vertical development. Vertical development of cloud. That is cumulonimbus. Now, in the case of cumulonimbus cloud, what are the associated weather conditions? We have, beautiful, very good, heavy rainfall, followed by thunder and lightning. In rare cases, you will observe hailstorms. That is also a possibility, but in rare cases. Okay, Pranay. Right. So that is what is a cold front. Now, in the cold front, the cold air sticks to the ground, hugs the ground, and the warm air, as it pushes into the region of the warm air is forced to rise up. That is a cold front. We have the opposite of it. That is when sometimes the tropical area develops an extraordinary high pressure, so the warm air is more dominant. Now, when the warm air is more dominant, you have the formation of what we refer to as a warm front. Now, what is a warm front? When we say a warm front, in this, the warm air moves into the region of the cold air, right? So, in this case, you have warm air pushes into a cooler region. Now, in this, what happens? Let us try to understand. In this, what happens? So, suppose, again, okay, I'll do one thing. I will place it here so that it doesn't mix with the color of my shirt. So let's suppose this is the front, or this is the shape of the cold air. So cold air. And here you have warm air. And it is this warm air which is going to climb. So let us suppose this. So this is, let's say, the boundary of the colder air. Now, in the earlier case, this was moving and it pushed the air up. Now, what is happening is you will have the condition where the warm air is coming. As it approaches the boundary, what will happen? It very easily climbs here. Observe that it climbs over a slant rather than being pushed vertically up in their own position as the cold air advances. So, rather than the cold air pushing into the region and suddenly pushing the air vertically, here the air rises very gradually. So as the air encounters the boundary of the cold air, the warm air being lighter, it rises like an inclined plane. So warm air being lighter, gradually rises up the boundary of cold air. Right? So in this situation, it is the warm air which rises up. So the front which will be created will be somewhat like this. Again, having the same shape. But this time the warm air will be rising like this. Warm air is rising very peacefully. So that is why in this case you will have stratus kind of clouds because of gentle rise. You will have stratus type of clouds. Right? And stratus, what are the weather conditions that are associated? You will have light rainfall, okay, persistent rains, which are going to continue for a long time. But then there will be a kind of a lack of violent thunderstorms and lightning. So here you will have lack of violent thunderstorm or lightning event. Okay, so we have seen stationary front, we have seen cold front, we have seen warm front. In each of these, what we have seen? What are the fronts? They are the boundary zones in between the air masses. Different air parcels, the boundary zone that you have, that is referred to as a front. Now, that boundary zone will have its own property depending upon whether it is the cold air which is pushing or whether it is the warm air which is pushing and rising up. In how the warm air rises up, as you can see, the type of cloud formation that varies, right? The type of cloud that you see to be formed, now depending upon the type or the kind of rise that the warm air indicates, all of that varies. The type of rainfall, the type of weather phenomena, everything changes. Now we look at the occluded front. So occluded front, it is a kind of a front which is created when the entire front is getting closed. Occlusion. What is the meaning of occlusion in English, by the way? Let me see how proficient we are in the subject in which we are going to write the exam. So, what is the English meaning of occlusion? Good. It is a kind of a closing up, right? The act of closing up, the event of being closed up. So, that is occlusion. So, occluded front is created when the front begins to close. Generally observed during frontal or temperate cyclone. Temperate cyclone. Now, when we say occluded front, how is it formed? And when is it formed? So for this, very briefly, I'll give you the image for the development of a temperate cyclone, which we will study in greater detail as well. But generally, here, observe the different phases of the temperate cyclone. Here, what kind of a front is in existence in the first image? What kind of a front is in existence? Good, Pranay. Very good. This is stationary, isn't it? Because you have the presence of warm air and cold air, but this is not moving. This is your stationary front. After some time, both the warm and the cold air, they feel uneasy being in the same place. They start feeling restless, right? So they want to enter into other territory. Just like after you read the same subject for a long time, you have a natural tendency. Let us explore what is there in art and culture, by the way. Then we will come back to the phenomena of albedo, etc. So that is where warm air starts entering into the portion of cold air. Cold air starts entering into the region of warm air. So in one region, you have the cold air which is progressing. In another area, you have the warm air which is proceeding. So here, what do you have? Which front do you have in this? This is a warm front, isn't it? And this is what? What front is this? Because the cold air is advancing, we can say this is a cold front, isn't it? Now, let us take two pieces of paper. Both the fronts, they are present across a kind of an inclined line. Fronts are not vertical, fronts are inclined. Why? Because the cold air has got a kind of a compressed volume. That is why either the warm or the cold front, you will observe that the boundary is inclined, it is tilted. So here, let us name this warm front as 1. Let us name this cold front as 2. As you can see with the next images, if this is the warm front, let's suppose, the cold front starts chasing it from behind. The cold front starts chasing it, it will get together. Now, when this gets together, what will happen? The warm air will be completely lifted from the ground, because if this is one, that is the warm front, warm air is automatically rising. From behind, you have the cold front, which is also coming in, and this cold front then meets here. So when both these fronts will meet, what will happen on the ground surface? On the ground surface, you will have the presence of only cold air, because the warm air simply gets lifted upwards, right? So here you will find that when both the fronts they will meet, then warm air is completely lifted off the ground. So in this case, warm air is completely lifted off the ground. And why is it that the warm air is completely lifted above the ground? Because you have the cold front which was chasing the warm front. Finally, they meet, and that is where we see that the front which had been created starts to close down. So that is because as the front closes down, warm and cold fronts meet. Okay, so that is what is referred to as the process or the act of occlusion. And what that creates as a result is an occluded front. So that is generally observed at the end stages. After this, you have the condition where the, as you can see, air starts becoming homogeneous. It becomes colder air at the ground surface. So after this, you have the conditions of frontolysis. Generally leads to frontolysis. And here again, guys, if I can give you a piece of suggestion, I would recommend you that kindly refer to the annotations of the class, because, and this I tell you from the fact that I have also come across many of the books in geography. I have also read many different books in geography. Nowhere will you find the existence or the explanation of front in a kind of a particle format or in the smaller format. In most of the books that you refer to, other than probably Stroller, and that is a book which has explained only with the help of images, there is no text that you will find. So in none of the books will you find the explanation for the frontal formation in detail, the climatic conditions that you experience, or if that is present, you will not find the explanation for tropical cyclone, temperate cyclone, and its formation in granular details. So that is why what I would recommend to you is, rather than fishing for various high standard books in the market, look at the annotations of the PPT. Because generally, let me tell you what happens with the mindset of the candidate. Candidates in general, and this you can relate to, candidates in general, they have a short patience level, very short patience level, and that is true for almost all the most of the candidates, that they won't spend too much time in understanding the basics of it. For example, you might have a doubt in your mind that, tell me why it is referred to as a cyclone. Now, even if I start from the basics, you won't have the patience that, first tell me why it is cyclone, then you talk all the principles, etc. So in that rush, many of the times we only skim through the surface of the topics. We are unable to internalize the topics. Not only do we lose interest in that subject, eventually, even after spending time, you will commit a lot of mistakes in that subject. It will lower your confidence, and prelims is all about the game of confidence. So you will not qualify in prelims, and you will blame a particular area or a particular subject. What should be done is, the basic books and the basic material, get into the depth of each one of them, spend some time, try to understand why this would have happened. rather than trying to simply rote learn or by heart. Try it to understand why. As I can see, many of you I have seen, and this journey I've seen for the past 10 days. For many of you, you have started to understand things in a much more better way. I'm not saying that this will surely make you successful, but that line of thinking is something which everyone has to inculcate. And that is something which will give you the critical think point for other subjects as well. See, many of the subjects you'll find to be very easy, where even after you miss 3 to 4 classes, fifth class will still make sense. That is the case with many of the subjects, but UPSC is a area where you have to read all the subjects. So even knowingly or unknowingly, you will have to study this subject. So better look at the basics, repeat this multiple times. What is a cold front? What is a warm front? What is occlusion? Why cold front? Where warm front? Have these questions in yourself, ask these questions, try to solve them yourself. Then you will reach a kind of a logical conclusion, and then what you internalize, that is something you will never forget. Okay, we had one such student in our previous batch who managed to do this, and thereby, just on the basics, he continued to repeat it so many times. He was able to secure a very, very good marks in the optional area of geography in the mains paper as well. He got through. So that is where I would suggest to you, stick to the PPT in these areas. Otherwise, the basic books are sufficient. Why is there a sudden rise of warm air mass in cold front? Because that is where this is Nandamuri. So that is where you will find that in the cold front, as this moves, warm air is lying static. As the cold front moves, warm air is forced to rise up. But in the case of the warm air mass, cold air is not moving, so this is able to climb it very gently. That is why. Okay. So now, XY. Sometimes we feel a sudden shiver passing through our body. Is that a cold front type situation? No, it is not a cold front situation. It is something else, right? And let's not go into what it is. So, Shrikant, I don't have the patience of reading books. Good that, Shrikant, you realize that it is a drawback. I, at least now, till now in my journey, I have never come across any candidate who has succeeded in this examination without reading books. You might set a new example for the future generations to follow. You never know. Be confident. Then we come to the portion of cyclones. Cyclones are relevant both for your prelims as well as for your mains exam. Prelims. Properties. Formation. Right? Then the difference between the types of cyclone. The types. In the mains, formation, then regions where they are formed, naming of tropical cyclone, and features. Okay, so here, that is what we have as cyclones. So let us first of all understand, what do we mean by a cyclonic and an anticyclonic circulation. So when we talk about a cyclonic circulation or cyclones are areas of extreme and intense low pressure. That is what is a cyclone, right? Now, why is it referred to as a cyclone? Because there is a circular movement of wind happening around this intense low pressure. So cyclonic circulation always will have intense low pressure regions initiating a circular movement of air. Anticyclonic circulations are intense high pressure regions again observing circular movement of air. So the wind circulation around a low pressure is called cyclonic circulation. Around a high pressure, it is called anticyclonic. Now, low pressure means what? It will attract winds from all direction. High pressure means what? It will produce wind and that wind will go in all directions. So observe the image here. When we talk about a low pressure or a cyclonic condition, you have a very intense low pressure on the ground. Now this will attract winds from all different directions. Now impacted by the Coriolis force which is in play, these winds, when they come to the low pressure, first of all, as they reach to the low pressure, they will also rise up. Maybe they will get heated up, warmed up, and they will also rise up. But will they rise up in a straight path? No, because the Coriolis force is at play. So they rise up in a kind of a curved path, as you can see. They will rise up in a kind of a curved path. And when they rise up, eventually their temperature will drop, the temperature will reduce, and you have a vertical column of air, even though it is rising in a spiral manner, but it is rising vertically. So what will it form? It will form very thick cumulonimbus clouds. Cumulonimbus clouds. And that will bring very heavy rainfall, thunder, lightning, etc. That is a feature generally observed across all the cyclonic circulations. Now, this is observed in various parts of the planet. Now, will it be observed at the region of equator? Let me launch a poll and let me get an answer. A, will it be will be observed at the region of equator? Yes. B, no. Will cyclones exist around the region of equator? Very good. Majority of you have given the incorrect answer, and that too with a beaming pride. Very good. So the question was, will the cyclones exist over the region of equator? The answer is no. Why? Because of a very basic phenomena that at equator, the Coriolis force is zero. So you might have the presence of a low pressure, but it will not be a cyclonic circulation. It will never be a cyclonic circulation. So these circulations don't exist at equator. Do not at equator due to lack of Coriolis force. Okay. Now, here It is the Coriolis force which is impacting the bend of the wind in general. That is why in the northern hemisphere they will bend to the right. In the southern hemisphere, the winds will bend to the left. In the case of an anticyclone, anticyclone is a kind of a high pressure. So here winds from above, they start sinking in. But rather than sinking in directly, due to the Coriolis force, they will also observe a bend, and you will find that the wind is coming down across a bending motion. As the wind comes down, it will get heated slightly. Because of the compression, the adiabatic heating, the wind will get heated ever so slightly. And that is where at the ground temperature, at the ground, it will exert a very high pressure, and you will have a deviation of the wind from that high pressure. So in the case of a cyclone, winds are attracted to the region because of low pressure. In the case of anticyclone, winds emerge outwards. Okay. Now, a cyclone, this is how the cyclone appears from the outer space. So this is where you observe that this is the spiral around which the winds are rising, and they are forming that spiral cloud in general. Now, the cyclonic circulations in the northern hemisphere and the southern hemisphere, they will experience different directionality of the wind. When we say circulations, cyclonic circulations, so circulations in northern hemisphere and southern hemisphere, they will be distinctly different. Why? Because the Coriolis force is different. How? Let us understand. Let us assume this is the low pressure region. Now this low pressure region, it will attract winds from all directions. From all directions, the winds will be attracted. From all directions. Now, as the winds are attracted towards this, what will happen? Due to Coriolis force, there is going to be a bending in the winds as well, right? So because of the Coriolis force, when we are in northern hemisphere, winds will bend to the right, bend to right. So here you will observe that the winds, they will bend to the right. Isn't it? Now, if you are an individual, sadly, because maybe you didn't get through the exam, you are made to stand at the center of the low pressure. That go stand at the center of the low pressure. And someone from outside asks you, what is the direction of the wind movement around you? What will you report? You will say that around me, you won't obviously be able to observe the wind here, 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 here. This is something you won't be able to observe. You will be able to observe only around yourself. So won't you report that around me, I see wind movement, which is in this direction? You'll be reporting that, isn't it? Now, what kind of circulation is this? Clockwise or anti-clockwise? This is anti-clockwise. So that is why cyclonic circulation in the northern hemisphere, winds will always move in an anti-clockwise direction. Whether that cyclone is formed over Atlantic, Pacific, Indian, Arabian Sea, Bay of Bengal, any ocean or any land area, it will always have a kind of an anti-clockwise circulation. In the southern hemisphere, it reverts. So let's suppose this is the region of low pressure in the southern hemisphere. Now, because it is extreme and intense low pressure, only that will lead to cyclonic circulation. So this will attract winds here, 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 here. But now, because we are in southern hemisphere, the winds will bend to the left. They will be bending to the left. Now this time, let's say, last time you were standing, this time you asked your friend that you go and stand at the region of low pressure. So your friend is standing at the region of low pressure. You ask your friend, what is the direction of wind movement that you observe? Your friend will say, it is moving like this around me. What circulation is this? This is clockwise. So the same low pressure creates an anti-clockwise circulation in the northern hemisphere and clockwise circulation in the southern hemisphere. Always cyclonic conditions, because you have rising air. Cyclonic conditions are accompanied with very heavy rainfall, thunderstorm, lightning events, visibility gets reduced, strong wind movement. That is something you observe in cyclones. Very dark cumulonimbus clouds will be created. Now, anticyclone. Anticyclone is the area where the wind is sinking down. Now, in the area where the wind is sinking down, here, will you be observing the cloud formation in this region? Will there be a cloud formation? Don't be so confident, guys. I will launch a poll. So let me see. At the region where the wind is sinking down, will there be a cloud formation observed? Thankfully, majority of you have given the correct answer in this case. Thank you so much for that. So there will be no cloud formation here. Why? Because for the formation of cloud, you need the air to rise up. That is what will lead to condensation, cooling of air, and saturation. Sinking air will never lead to cloud formation. Never. In no condition will the sinking air lead to cloud formation. So observe the image here. Image here, you will observe this is the region where the air is sinking. Right? This is the region of sinking air. So what happens on the ground? On the ground, this pushes the air outwards in all directions from that center. So here again, you will have different types of circulation. That is where different types of circulations both in the northern hemisphere as well as in the southern hemisphere. So when we talk about northern hemisphere anticyclone and southern hemisphere anticyclone, these are regions of high pressure. High pressure means that wind will originate from this and move in different directions. In northern hemisphere, we know that because of Coriolis force, winds will bend to the right. So here, as the wind is moving out, they will experience a bend. They will experience a bend to the rightward direction. So that is when they will experience a bend to the rightward direction. Now, again, do the same exercise. If you are standing here, someone asks you, my dear friend, what is the direction of the wind? What will you say? Around me, the wind is passing like this. So what is this? This is clockwise. Cyclonic circulation in northern hemisphere was anti-clockwise. And anticyclonic circulation is clockwise. Now, in the southern hemisphere, again, the winds will originate, will move in different direction, isn't it? But here, this time, they will bend to the left. So that is why they will be bending to the left. Now again, do the same exercise. Stand in the center of high pressure. Look at it, which direction the wind is moving around you. It is moving like this. So what is this circulation? This is anti-clockwise. Anti-clockwise. So that is why when you have the condition of cyclone or an anticyclone, the circulation which is achieved in northern and the southern hemisphere, they are going to be distinctly different. This is the portion for a kind of a summarization of what we have done. This is for those who believe in learning everything with a glass of water. You simply wrap up the paper, mug it up in, gulp the water, and next day in the exam, you vomit it out. I would not recommend that. I would suggest all of you, please do not learn it. Please do not learn it. If you really want to understand this, please do not learn it. I have put this only for those of you who don't find any other way. I would suggest to you any piece of paper that you have. After the session, draw it randomly in rough. Randomly draw it out. That, okay, low pressure winds are coming, northern hemisphere rightward, southern hemisphere leftward. What is the circulation? So that will give you the ability to arrive at this conclusion without any probability of a mistake. You will never commit mistake if you are drawing it on your own. So do it on your own, and that will be more than sufficient. Okay. So that is where we'll restrict the session here today, guys. We are moving out of time. And tomorrow, then we will cover the portion of cyclones. And tomorrow, we are also going to get into heavier topics. That is Enzo cycles, that is El Nino, La Nina cycles, Indian Ocean dipole, and jet streams as well. So what I would suggest to all of you is that tomorrow, before coming into the class, kindly, please, and another form of request, if I'm missing the vocabulary, all the forms of request I submit to you, please take a look into the world atlas. What is Pacific Ocean, where it is? Look at what is the eastern side of Pacific, western side of Pacific, which are the countries there. When we say eastern side of Pacific, what do we mean by that? When do we say western side of Pacific, which countries are we referring to? Similarly, take a look at the Indian Ocean. What are the regions in the eastern part of Indian Ocean and western part of the Indian Ocean? I hope this is not too much of an expectation to place before you come to the next class. So we meet again tomorrow, and that is when we will look at these particular topics. So that will be all from my side. Okay. And a couple of questions we will take, and then we'll end the session. Pratyaksh, we have been talking a lot about rising and sinking of air at different instances. Will these happen always in circular fashion due to Coriolis force? No. No, Pratyaksh. So see, if you have that low pressure or high pressure concentrated in an area, that is when it will start circulating around the area. If you have a low pressure developed over a wide belt of sorts, that is when, as the winds will rise up here, it will experience a bend, but in the same direction. There won't be circulation. Okay. Thank you very much for the kind words. All of you, Pranay, Manish, Shamil, Deepika, thank you. Gagan, by homogeneous, do serve mean diffusion of particle, that is particle gaining same temperature by intermixing of particles. But won't it be the case anytime two fronts collide? No, no. See, if it had been Gagan, I think your question is that when we say that the air parcel is air mass is over a homogeneous area, it gains the property. Homogeneous here refers to that you have the same region. For example, if there is desert, the entirety of North America is desert. So the air mass above it will have the same characteristic because the homogeneous conditions on ground. If on the other hand, here you had sea, then you had desert, then you had mountain, then you had a forest. This is non-homogeneous surface. Non-homogeneous surface. Okay, I hope this is understood, Gagan. And also, after some time, in the case of stationary front, we have seen that after some time, anyways, if the front is not moving, the air tends to gain each other's properties, but that happens after some time. No, intermixing of particle, Gagan, why will the intermixing of particle take place? Imagine and think about it. The air, cold air coming from the polar region will have a very distinct property as compared to the warm air coming from tropical area. Very different property. And it is not as if 1 kilogram of cold air has come. Now the polar region has gone for a holiday. 1 kilogram of warm air has come and they are fighting that who will form a front. No, it is a consistent supply. So consistently cold air is made cooler by the winds coming from the polar area. So their identity is retained. Consistently warm air is getting warmer because of the supply of winds from the tropical area. So their identity is also maintained. And when they move, when they interact, they will have individual properties of volume. So they will, rather than spending some time here getting to know each other, they will start climbing upon each other. That is the front. Okay. Sumit, sir, at equator, we don't find cyclones because of absence of Coriolis force. Will the intensity of cyclone increase going towards poles? Yes. Very good conclusion. Yes. And in occluded front, why cold air comes from behind the warm air? That is where the cold air starts. See, as we come into the portion of temperate cyclone, we will talk about that why there is that low pressure. As of now, just understand that cold air is chasing that low pressure region which is formed in that area. We'll talk about it tomorrow when we again discuss about occlusion and the occluded front, Devansh. Okay. Sachin, is it necessary for ourselves to prepare own notes? This is a controversial topic. Many of you get recommended that don't prepare notes, and you become very happy that this is a nice guy. He's telling us good things. So let me tell you something controversial here, that preparation of own notes is an absolute must if you want to really capitalize on the mains exam. See, if the aim in your life is that I will attempt the civil services examination, if I do my level best, I will get through the prelims. If you are not able to visualize beyond prelims, fair enough. Preparation of notes is not important. When you talk about mains examination, if you really want to get a good rank, that is based upon mains marks. And in mains, in GS paper 1, you have 4 to 5 subjects. GS paper 2, 2 to 3 subjects. GS paper 3, 4 to 5 subjects. Now, from paper 1 to paper 2, you get a gap of 2 to 3 hours. In that, you have to gobble up your lunch as well, right? So, all that time which is left for your revision for paper 2 is around 1 hour or 1.5 hours. Similar is the case with paper 1, paper 3, paper 4. So, in case you have not prepared your own notes, you are bound to open up the books at that point of time. And that is the worst thing that you can do, because neither will you be able to complete a book in that short period of time, either by revision or any process. And secondly, you will go to the paper hall half baked. So always what I advise to all of you, in case you want to follow it up, see, there are people in the market who will tell you that don't prepare notes, go the easy way. They will also tell you don't study newspaper, look at the analysis. They will also tell you don't study books, just read at the gist. So ask those people to try this exam once on themselves based upon this and try to succeed. It is absolutely impossible, I will tell you. So what I would suggest to you, once you have read a particular topic, any topic for any subject, from all the sources that you are referring to, read a topic, write that topic in your own words in the briefest possible manner. And the briefest possible manner, I mean to say, for example, the entire plate tectonics and continental drift theory, once you have read through it, you should be able to concise that or have a summary of that in one A4 sheet paper, 2 sides. That is how brief you should be. That is the note which is going to help you. The other section of the population is which is going to who is going to look at the book, start copying, and today I have finished 2 pens, 15 pages. So you are nothing but a glorified paper copier. You should keep your name Xerox. So don't be a Xerox. Try to write it on your own. That is when your writing skills will improve. That is when your memory to muscle, that retention will improve, and you will have a better recollection as well. Okay. So that is where we'll end the session here. Um, and we'll meet again tomorrow. Yes, Devansh, that is correct. And Satya, yes, that is perfect. Okay. Then Meena, I'm only focusing on Baiju's book, PPT, and additional reading. More than sufficient, my dear friend. Other than that, Meena, just be regular at newspaper reading. That is all that I will ask you. Anil, is frontal scenario is not happening in valleys? No, no. Till now, we have not seen any scenario where frontal or the front formation is taking place. Okay. Hailstorm are formed at clouds at minus degrees after the. So hailstorms are always formed when you have, see, cloud in themselves are formed when the saturation point has already been breached. Only then. And hail is formed after repeated upward and downward movement when it melts, refreezes, grows larger, melts, refreezes. That is what happens. And Vaishna, I find it important to internalize the concept. That is true. That is all that I was trying to say. And the formation of fronts change with seasons. Sukanya, absolutely yes, with the shifting of the pressure belts. So that is where I'll end the class, guys. Few of the questions I have not been able to answer. Don't worry, our SMEs are here for some time. They will get back to you. If still the answers are not given or the questions are not replied to, feel free to write to us at IS Live, Target IS, or you can write personally to me as well. So we meet again tomorrow. Take care of yourself. Goodbye. Thank you and have a good night.